in this presentation, we, Holger and I, and also Simon is co-author, we are a team from the University of Zurich. We will give you an overview of global climate change impacts on glaciers and associated risks, turning also then to early warning. First, I would like to briefly introduce our team in Zurich. Next slide. We are a team of 6 people currently. 4 are here represented in the meeting. 2 of them will join later in the year. I think we are quite well-equipped team with different capacities and expertise, also more senior people and more junior people. We have expertise in on-site in the field for many years, Earth observation, satellite, and modeling of glacier lake outburst, floods, and also technical expertise in computer modeling and on-site with instrumentation. Personally, I have more than 20 years of experience working with glacial lake outburst floods in different regions of the world, also with monitoring and early warning in several regions. Personally, when I remember when I started my PhD back more than 20 years ago in the topic of glacial lake outburst, floods, debris flows, mud flows, I was always very much impressed by the research that was done in the region in Central Asia on mud flows. We know that it's a very important research, and also mitigation measures which are pioneering. And I think especially the decades of the 50s and 80s are considered the golden age of mud flow research, with very important research in the region in Central Asia. And I don't know, maybe your parents or grandparents have also been part of this research. And it's also very important that we consider and evaluate and reanalyze all these experiences that have been made previously, and also what we see today. For instance, the mitigation measures, I was always very much impressed by the structures that were built at the time, also in more recent times, for instance, in Kazakhstan. So this is very good ground, and we are really very happy to be able to collaborate with you. And of course, I mean, this is new times now. Everything is online, but nevertheless, I mean, it's very important that we all also, our team in Zurich, we are on site and we collaborate with you face to face. So we hope the best that things are improving in terms of the pandemic, and that later in the year we will be able to travel to Central Asia and also know you personally. I think this is very much important, and we are looking very much forward to that. So briefly about glacier mass changes. This is, Anil has mentioned, this comes from the World Glacier Monitoring Service, a important global study. You see Central Asia also represented here, here in orange, which means it's quite strongly affected by glacier mass loss, glacier shrinkage over the past 50 years, but you also see the other regions that are important, of course. So we have faced already very important glacier retreat, and this, of course, has a lot of consequences. Next slide, please. In Central Asia, there has been a very important measurements starting around the 50s here during Soviet time. Then we have after the Soviet Union, you can see that there was a break. However, these mass balances in glaciers could be reconstructed due to important efforts, and now we are back. You know that on several glaciers like Abramov, for instance, or Golubin. So you see, I mean, all the glaciers are in continuous retreat and strong retreat, and we have accelerated shrinkage over the last 10 to 20 years. Next, please. Now the future also doesn't look very bright. However, it's also important to say that we do have a handle, and these are the differences are in the blue and the red lines. The blue lines is a better sort of a better future when we are able to mitigate, to reduce CO2 emissions effectively. If we are not able to do that, then this is the red one, a high emission scenario, and you see this will much more heavily impact still in the glacier retreat and associated impacts and consequences and risk for high mountain nations. This is a very big region. This comes from the IPCC report, by the way. But you see that the difference is something maybe from, we can still preserve something more than 50%, maybe 60% in a better scenario, and maybe only something like 30% in a worst case. Next one, please. It's important that we have a comprehensive perspective when we talk about glacier shrinkage and impacts. And I think Shamila has given a very good introduction and overview of that. And this is just briefly to mention, we have climate changes, as you know, is impacting heavily glacier, and also the formation of glacier lakes. This has impacts on water, on natural hazards. This is our main topic, the natural hazards related to the lakes. But it's also important for ecosystems. And then this is also very important, so sort of on the socioeconomic level for agriculture, hydropower, and sociocultural activities. And in this project, because it's also an adaptation fund, we have a major focus on adaptation. And I just want to mention here that we are navigating here in disaster risk management, broader also in water resource management. Capacities and governance are extremely important, and you know that capacity building, strengthening capacities is a very important component of this project. The next, please. So this is an overview, also a recent study, global study about actually lake and reservoir volume in high mountain areas, triosphere mountains of the world. You also see represented here Central Asia with quite important reservoir volumes. Next slide. Now this this means that there are many glacial lakes, and some of them are dangerous and are threatening downstream population. In the Andes, in South America, Peru, we have done such research about looking in detail about glacial lake outburst floods on the past on the left, but also potential future glacial lake outburst floods. And we have distinguished between low emission scenarios and high emission scenarios. So what we've seen previously about high levels of warming and lower levels of warming, and what this means for these populations in the Andes. Next, please. Now, in a broader, as we talk here also about the broader picture and also the international sort of tendencies which go more into integrated approaches. Of course, what is also, we know that is also important, including from glaciers and snow, of course, is very important also for agriculture, irrigation, and other purposes. This and Central Asia is also depending quite importantly from glacier meltwater. Next slide, please. Actually, Central Asia has been identified as a global hotspot region in terms of the importance of glaciers for water resources. What you see here, this is, you see the main Central Asian catchment, and how those can change in the future in terms of the importance of the glacier melt, and you see here the color is clearly very marked. So this is something that we need to be aware of as well. And next slide. And also here, this is a concept of peak water. So when you have glacier melt at some point, there is a maximum of water, and this then often sharply declines. And you can see here this peak water for most of the region is around to be passed. Now the project focuses on glacial lake outburst floods, monitoring and early warning. But something that we have really learned is it's very robust evidence when we are working with local people and when we're implementing early warning system. This is, I mean, at the end of the day, we want to protect people. We want to reduce risks. And then this is very robust evidence. We need to have a relatively broad approach. We cannot just, we cannot ignore the other concerns, the other risks that people feel because of the extremes, and the extremes are very dangerous. The glacial lake outburst floods are the most extreme floods we probably can have on Earth. However, people are also concerned with other types of risks, and we need to acknowledge this. This is very important. Otherwise, and the experiences show this clearly, otherwise early warning systems will not be effective and successful. And this is also why we're mentioning here also the water issues that we need also to consider, even though this is not the main focus of the project. Next slide, and I think then.
Yes, thanks. So, yeah, thank you. If we zoom in a bit more locally on this glacier retreat, we have here an animation of glacier retreat from the Swiss Alps, about 100 kilometers away from Zurich, where we are working. And you see, while the glaciers retreat, you see these blue areas coming up, being exposed. And these blue areas are new lakes that are forming at places that have been covered by ice before. And actually, this is an animation that starts already in the 1990s. And at some of these places, we can already now see and observe in nature the formation of such glacial lakes. And this is a phenomenon we can observe in all glaciated mountain regions of the world. Now, what's the problem with these glacial lakes? These glacial lakes, on the one hand, are really nice and attractive elements of the landscape of these deglaciating mountains. They can also provide important opportunities for water management, but at the same time, they are the source of potential hazards and risks. And you see here, this is a satellite image from Peru. And you see, this is the glaciers, the white areas on top of the mountains. And this blue line demarks about the potential reach of typical mass movements we have in these mountains, such as ice avalanches, snow avalanches, rock falls, landslides, etc. They're normally quite confined to the high mountain, to the glaciers, to the steep parts. But now we have these glaciers and these glacial lakes. And these glacial lakes can burst out, and as soon as water is involved in these processes can have a much further reach, and they can actually reach further down into the valley, into the main valley, and to the sites where we have settlements, where we have cities, where we have infrastructure. And that's why these glacial lakes are really a multiplier of the distance of the reach of such hazards. That's why it's important to consider these lakes and also to manage the risks related to these lakes. If we look at the history of glacial lake outburst floods at the global scale, that's what you see on the left side. This is a study that investigated all the reported glacial lake outburst floods at global scales and in different regions of the world. And you see that since the first half of the 20th century, the number of glacial lakes is increasing at global level, but also at different mountain ranges. I show you here the European Alps as kind of our home, and the Pamir and Tian Shan mountains as the focus of this project. And you see they're both following a similar pattern with increasing frequency and appearance of such a lake outburst floods. On the right side, the graphic you see is a new study that was published end of last year, which shows that probably these numbers we have been using in the past, also on the left side, are underestimating. The study found much more evidence of other GLOFs that have not been reported so far. And here important also to mention, as Christian already pointed out, especially in Central Asia, where we also have a long standing research tradition on this glacial lake, not only Lake Merzbacher that you see on the image, but also many other more moraine dammed lakes in Central Asia. So this is the picture of the past until today, if you want to say so. But now we also have to look into the future, because glacier retreat will continue, and so will continue the formation of new lakes and their hazards and risks. And a study that is now to be published in the next coming days, actually we found that the GLOF risks will increase by the end of the 21st centuries in the Pamir region by a factor of maybe 5, and in Western Tianshan as well, at least by a factor of 2 until the end of the next century. And the map you see here is a map of possible trajectories of future outbursts. If these lakes form at some point in time in the future, they have the potential to produce outburst floods, and these outburst floods can of course then reach down valley, downstream, and also affect infrastructure, people, settlements, etc. Now, if we speak about the risks associated to these lakes, it's important to not only consider the hazards, so the physical processes of the environment, but also to consider the potential losses and damages, so the negative outcomes of such hazards. And if we take here the risk concept of climate-related risks from IPCC, we see clearly that risk comprises not only the hazards, but also consists of the other elements, which are exposure and vulnerability. And if we apply this to glacial lake outburst flood risk on the right side, you can see basically the red dashed line that's outlining the hazard of such an outburst flood. But then we also have to look at the people and the infrastructure that's potentially affected by this outburst flood. And so this infrastructure, these assets, these people, they also have a certain vulnerability depending on their socioeconomic conditions. And we really need to take this integrative perspective to efficiently manage also the risks that are associated to these glacial lakes. And I'll, on the next few slides, walk you now through these 3 different components of glacial lake risks and how we assess them and how we try to manage GLOF risks. So speaking about the hazards, you already saw in the previous slides an example from Peru. This is here an example from an Indian state in Uttarakhand, where we really at an overview scale assess the GLOF hazards. And you see this can be done by a large number of lakes, maybe 100 lakes, not only for current conditions in the center, but also on the right side for future conditions. And this is very important to also in the planning of the management for such hazards and risks to take this perspective and have this future-oriented perspective. And based on such an overview study, we can then also identify hotspots and critical cases, priority lakes, and have more detailed looks and more detailed investigations at a specific region or at single lakes. This is what we show here. And then if we speak about individual cases, we really have to consider the whole chain of processes in detail. So for instance, a mass movement that could trigger a wave, or processes at the dam that could lead to dam failure, dam erosion, overtopping of the dam, and eventually the GLOF, the outburst flood, the debris flow that emerges from these lakes and continues downstream and affects population and infrastructure downstream. One result of such investigations can be such a hazard map, which is then at the same time already an important tool for analyzing the exposure, because we can see now which areas, which settlements, which houses, which infrastructure can be affected by a lake outburst flood. And this can then be used also for disaster risk reduction by, for instance, defining the evacuation routes, by defining safe zones, etc., as done here in this hazard map. Then also the reduction of vulnerability and is mainly related to capacity building, which will also be an important component of the project we are talking about here. And basically we can separate this into 3 different areas of capacity building. And on the left side, most importantly, the collaboration with the potentially affected communities. And actually, I don't like the word capacity building too much in this context. I would rather suggest to call this knowledge exchange, because as Christian mentioned, it's very important actually also to get the local knowledge of these people. They know the situation very well, and this local knowledge is very important also to understand the history and the framework conditions of a current situation. And of course, also to really get or take into consideration the risk perception of these local communities. Then in the middle, the inclusion of processes and protocols on the institutional landscape to have the public institutions prepared to manage GLOF risks and also to be able to respond efficiently in case of an event. And on the right side, in the end, courses at university level. This is on the first hand important to also make sure that we have for the future new specialists for academia, for science, for public institutions, but at the same time also to train the current experts and professionals on the specific latest developments and tools and needs to assess and manage the risks related to glacial lake outburst floods. And the last point of our presentation, which is also key for this project we're talking about here, is early warning systems. Now, early warning systems currently are a really high-level item on the international policy agenda. For instance, the Sendai framework for disaster risk reduction. Early warning systems have a very prominent role. And very important is to be clear that these early warning systems, they consist of 4 different components. It's not only the monitoring and warning service, what you see on the image here in the background, but it also consists of a detailed risk knowledge of dissemination and communication aspects and of response capability. And taking this integrative perspective and approach to early warning system explains directly that these early warning systems are really highly complex systems that need to consider technical, institutional, social, and legal components at the same time. But if well planned and successfully implemented, these early warning systems can be a very efficient tool to reduce vulnerability, to reduce exposure, and therefore to reduce risks related also to glacial lakes. So these 4 components actually is what we have just tried to show you in the first few slides here. So risk knowledge is basically what we get from the process investigations, from the hazard modeling, from the future perspective of hazard development, for instance, for hazard map. This tells us everything we need to know about the processes involved. Then the monitoring and warning system is, of course, a technically challenging issue. This is also what you see in the field by instruments, sensor, etc., communication infrastructure. Communication is more the institutional side, also collaboration with the affected population to be clear who has to do what, to take which decision based on what information. And eventually the response is very important, that people and authorities need to know how to respond in case of an event detected or a negative development detected by the early warning system. So to conclude our talk here in the first part, we hope we could show you that this glacier retreat is a global phenomenon. They are currently strongly shrinking, and this will continue in the future. However, the future development still depends a lot on our current decisions and measures we take on reducing current climate change. And related to these future developments of glacier retreat is also the future development of glacial hazards and glacial risks, especially in terms of glacial lake outburst flood. But these future risks, they depend also on the socio-economic pathways we are taking. So it's not only glaciers and glacier retreat that determines future risks, but also socio-economic developments. Then glacial lakes can really act as a multiplier in the reach of potential glacier hazards, because these glacial lake outburst floods have a huge potential reach, and we need future-oriented and integrated approaches to assess and manage hazards and risks related to these glacial lakes. Then the early warning system to reduce GLOF risk need to consider these 4 defined components, and this integrative approach is basically a must to have a successful implementation and operation of such early warning systems. And last but not least, to stress again the importance of risk perception that has to be taken into account for a successful implementation. So with that, dear colleagues, it's really a pleasure for us to collaborate with you on this challenging and important, but also fascinating topic in the next coming years. And we're looking very much forward to this collaboration. Thank you.